conducting the test, vendor personnel start the pump and bring the flow to the rated point. They let the pump run briefly to establish a stable flow and monitor pump parameters to ensure that all equipment is operating properly. Stable suction pressure should be maintained at each point. After that, test personnel should collect performance data as well as the vibration and temperature readings. Submitting result of the test, vendor should prepare a test report that includes all data collected, performance curve and vibration graph to the purchaser for review and approval. The pump should not be released for final inspection unless all the documents, including the test reports, have been approved by the purchaser. And final inspection should be conducted in 2 stages. When the pump is fully accessible for dimensional and visual inspection, and 2, when the equipment is prepared for shipment. Dimensional and visual inspection typically used during the following documents are typically used during final dimensional and visual inspection: data sheet, pump train general arrangements, auxiliary pump general arrangement, PNID, process and instrumentation diagram, bill of material for seal reservoir, LOS, seal, driver, junction boxes, packing list. During visual inspection, verify the following checks. All assemblies should be accessible for maintenance, disassembly, and gasket replacement, and match the general arrangement and piping isometric drawings. Valve handle should have enough space for safe open-close action by an operator to prevent hand jamming and injury. All equipment should be mounted securely and according to the drawing. Workmanship of installation, welding, wiring should be without visible defects and comply with standards. There should be no equipment or piping extending beyond the perimeter of the base plate, except those shown on the approved GA drawing. Painting and paint thickness should be inspected and verified. Quantity, condition, and packing for the items shipped loose should be inspected and verified. Packing should be sturdy and compliant with the purchase order requirement. And drivers, the inspector should ensure that the motor nameplate matches the requirement for motor data sheet. Major components of electrical motors such as stator winding, rotor, shaft, bearing housing and bearing may require entity test and material certificate as per the data sheet. Ensure that material certificate and entity reports have purchaser approval. There are electrical insulation tests that are performed motor parts such as stators and windings before the motor assembly, and tests that are performed on the assembled motor during motor routine or complete test. The source inspector should be aware of the requirements specified on the motor data sheet and confirm their completion and acceptance if required as part of purchase requirement. Motor routine testing to ensure freedom from electrical and mechanical defect is mandatory for each motor. So each motor needs to be tested. Motor rotor should be balanced and residual unbalance checked if required on the data sheet. Test reports should be submitted to purchaser for review. Main purpose of complete test is to determine accurate motor efficiency, power factor, and torque values under different laws. The oil condition should be checked after the test. Oil should be clean, should not change color when compared with unused oil. Hydrodynamic bearings may be removed after the test and inspected for excessive and uneven wear. Foreign material inclusion, hot spot, other signs of unsatisfactory performance. And motor final inspection includes inspection of dimension per motor general GA drawing, paint inspection, instrumentation inspector per motor data sheet and PNID, name tag, nameplate inspection, main terminal. So here this shows the shaft of a motor plus the stator and rotor and the casing in the electric motor. Gears used to either increase or decrease RPM from driver RPM or change direction of force. So They just sort of synchronize or direct the force of the pump. Gears are used with rotating equipment when drivers rotate at a speed either higher or lower than the required speed of the driven equipment. Another application of gears with pump is right angle gear. The pump driver is horizontal machine and the pump itself is vertical. For example, right angle gears can be found on pumps in fire water and cooling water pumps. Gears should be at least one low speed and one high speed shaft. Slower shafts have the largest diameter gear, which is referred to as gear wheel. Faster shafts have a smaller diameter, which is called a pinion. So that's why they got wheel and pinion, the gears. Gears should be designed for full operating speed range, including trip speed, and API 677 is the standard for general purpose gear units. Source inspector should check gear data sheets for instrumentation requirements, and main gear parts are casing, gearbox, gear wheels, pinions, shafts, and bearings. Casings can be fabricated or cast. Steel is typically used for fabricated casing, while steel or cast iron is typically used for cast casing. The casing has a bottom half that can also serve as an oil reservoir. So the gear and pinion, this is a pinion, this is the largest one, is the wheel, and this is the pinion. Gearboxes are typically split horizontally into upper and lower half to allow for mounting without distorting the casing and internal gear alignment. And as you can see, is a cross section of gears box. Gear casing should be checked, should be given a fluid fill leak check to test for oil tightness, and gear pressure loop oil system component should be given a hydrostatic test. The typical gearbox shaft should be made of one piece, heat treated, forged or hot rolled steel, and shall be accurately machined throughout the entire length and suitably finished at their bearing surface. Additional NDT requirements are also part of shaft manufacture. Gear manufacturer should provide an ITP quality plan based on API 577, as well as the purchase order, job spec, or test requirements. Acceptance standards shall be documented and agreed by the purchaser and vendor. Gear rotors shall be balanced like a pump rotor. If specified, a residual unbalance check should be performed. Testing of gear. Mechanical run testing shall be conducted by operating at the maximum continuous speed for not less than 1 hour after bearing temperature and lube oil temperature stabilization. The contract bearing shall be used in the machine for the mechanical run test. Testing with contract coupling or coupling is preferred. During the run test, the mechanical operation of all equipment being tested shall be within the defined limits. The vendor shall keep a detailed log of final test, making entries at every 15 minutes interval for the duration of gear test. Each entry test shall record the following: oil temperature, inlet pressure, outlet oil temperature, vibration amplitude, and bearing temperature. The source inspector should confirm that the vendor has documented the conditions of the test and that all readings were correctly recorded with devices that are within calibration period. Any run test is complete. After the run test is complete, the tooth mesh shall be inspected for surface damage and proper contact pattern using a blue dye, for example. When spare gear elements are ordered, each spare element should have a mechanical run test. So remember, the spare also done a mechanical run test, and final acceptance of mechanical run test of gear, the responsibility of purchaser, not the source inspector. So remember that you are not, as a source inspector, approving the mechanical run test. Final inspection and shipment. Final inspection at the gear manufacturer facility should be performed in accordance with the approved packing and shipping procedure and relevant documents. Painting, tagging, final marking, and cleanliness should also be checked per purchase order and specification during final inspection and shipment of gears. Steam turbines. Steam turbine converts the thermal energy from the pressurized steam and convert it into mechanical work by rotating output shaft. Governing specification of steam turbine used in oil and gas industry may be API 611. As you can see, the turbine works the reverse of a pump. So it is actually using pressurized steam and converting mechanical work. It's the other way around. So that's hence the steam turbine. The steam turbine vendor should provide the following documents that would be used during the final inspection: GA drawing, steam turbine datasheet, performance characteristic curve, instrumentation and piping diagram, condenser and ejector general arrangement, turbine trip and throttle valve cross-sectional drawing, manual and mechanical trip linkage drawing, gauge board assembly, electronic governor operation, trip and throttle control general arrangement. Each steam turbine has an emergency trip mechanism to protect it from overspeeding. The overspeed trip can be either a mechanical or an electronic device. Design and construction standards. Major parts of a steam turbine are pressure casing, rotors, bearing housing, governors, speed control mechanism, seals, gland seal system, and overspeed trip mechanism. The casing of steam turbines consists of a high pressure casing and lower pressure exhaust casing. Both parts are casings, and the most commonly used material is carbon steel. And most common material for shaft is steel or carbon steel alloy. As you can see here, this is a stator, rotor. One is stator, the other one is rotor, and this is sort of several stages, and then you have the whole casing on the that covers the whole steam turbine. Seals and packing. You can see here the close view of seals. There are different 3 or 4 seals, one after another, for more reliability. And a carbon ring. This is another view of the seals and rings. And then you see a shoe and beveling plate. It's like a clutch in a machine in a car. And also here you see a condenser. It's like a heat exchanger. Tubes, steam comes in and then goes out from here, and then the heat is observed here. Component inspection. Turbine vendor should provide a ITP listing all the requirements for inspection and testing, and this component may include the following: pressure, casing, blade, wheel, all blading, shroud, pinning wells, shaft and visual inspection, material certification, rotor balancing, hydrostatic test, cleanliness inspection of assembled steam turbine, auxiliary equipment inspection such as condenser and ejectors. Testing of steam turbines should have a mechanical run test, and the procedure for mechanical run test shall include selected running speed by the governor. Turbine is tripped when running speed exceeds the maximum trip speed. The hand level trips the steam turbine as per 611 or 612 with maximum inlet steam flow and pressure. The ability to reset the manual trip back to its operating position under maximum inlet in steam pressure. If turbine has hydraulic actuator and a minimum oil pressure, the turbine will trip on low oil pressure level. Check relief and the sentinel warning valves for proper operation. Job vibration and temperature instruments should be used during the mechanical run test. Pilot acceptance of mechanical run test is the responsibility of purchaser and not the source inspector. And the following documents are usually required for steam turbine final inspection: data sheet, P&ID, bill of materials, instrument list, general arrangement, packing list, shipment, and preservation procedure. And typical inspection points are: verify all the dimensions according to GA, check all flange screwed customer connections as shown on GA, and also check flange sizes, type, rating, and protection for shipping. And connections need to be plugged for the shipment. Source inspector should verify tagging of equipment and instruments per drawings, verify that all testing and final documentation is correct. Lube oil systems for pumps and their drivers should be designed as per API 614. Each system consists of a reservoir, pump, cooler, filter, connecting piping, pressure controlling valves, safety valves, temperature control valves, pressure, temperature, oil level measurement instruments, indicator, gauge panel, termination box, and mounting base plate. Reservoir stores the oil and typically has a level gauge, level switch or transmitter, oil heater with thermostat, temperature gauge, and temperature transmitter. Typical inspection points for the lube oil system. The following are recommended inspection points the source inspector should familiar with. During the inspection of lube oil system, the source inspector should follow the ITP for actual inspection points, check the actual oil leak tank with the LOS datasheet, lube oil system datasheet for all points. The source inspector should open the service access and make sure that there is a separating screen with its bottom sloping away from pump suction. Check if the minimum maximum oil level are shown on the level gauge indicator. Verify that all return pipes under the reservoir above the maximum operating level. I think it's 2-inch minimum. The source inspector should verify that the oil heater hot section is located at least 2 inches below the minimum oil level. Source inspector should check for grounding clips for lube oil pumps. Verify that motor nameplate in compliance with area classification. Verify setting of pump oil pressure relief valves. Make sure the pump casing is made of steel. If the pump is located outside the oil tank, pump casing may be cast iron with the pump installed inside the oil tank. Coolers, typical inspection point. Compare the cooler with the lube oil system datasheet. Verify all options. Verify nameplate and stamping. Verify if the bundle can be removed without obstruction. And in case of dual cooler design, source inspector verify that switch valve is easily accessible and operates without obstruction. Mounting base plate should verify all welds are continuous. Verify the drainage from the base plate is unobstructed. Verify that each closed compartment of the base plate has a grout hole and a vent hole for grouting, and verify that leveling screw is provided next to anchor bolt holes. For instrumentation and electrical system, check the nameplate, verify the pressure and temperature indicator, verify the indication instruments located in such positions. The dials are readily visible for reading, and actual inspection points are identified in the inspection test plan. The typical lube oil system with piping, tanks, level gauge indicator, and all the connections and panels. Performance test. Oil pressure limiting valves operate smoothly. Verify piping should be sized for a full flow of pump. Valves should not chatter. No excessive noise. Scope of supply includes lube oil system. System needs to supply regulated oil as standby accelerated. Verify all instruments show reading in required units. Calibrated shop instruments are used to verify flows, pressure, temperature. Test both main and standby pumps. Test both pumps operating at the same time to ensure system stabilization. Test the standby pump when the main pump trips to ensure standby pump will pick up pressure without tripping the system due to low pressure. Reverse process should be completed if the capability is available. Both main and standby pump should be tested individually to ensure proper system operation. Confirm vendor has conducted a system cleanliness test as per API 614. After all test runs are complete, filter elements should be inspected and replaced with new ones. Document and notify the purchaser of any changes, modification made to any components during the oil system performance test. Final inspection and shipment. As a minimum, following documents supplied by the lube oil system manufacturer typically required for final inspection. Review ITP and purchase order. API 614, lube oil system data sheets, PNID, bill of materials, instrument list, data sheet, lube oil system general arrangement, packing list, shipping and preservation procedure. Final inspection of lube oil system should confirm that all open flange face have face protecting, covering with gaskets. All dimensions were verified per the GA. All connections have tags. The piping arrangement allows easy access to all control and safety valves. Handles of valves are installed per the purchase order requirements. There is a clearance to allow safe opening. No equipment of piping hang over the base plate perimeter. All assemblies are accessible for maintenance, disassembly, and gasket and replacement, and match the GA, general arrangement, and piping isometrics. All loose items should have tags and should be listed in the packing list. Final packing should be done per an approved preservation and packing procedure. Reciprocating compressor is used for services with low capacity and high differential pressure and should comply with API 618. And as you can see, there is a piston and mostly used with process gases, and it's like a car engine reciprocating compressor. A special attention should be paid to materials if compressor parts shall be exposed to H2S or sober service. In this case, the material should comply with NACE 175 and include all pressure containing cylinder parts or components with cylinder suction discharge. Piston rods should be coated with wear resistant material. For compressor with power above 100 kilowatt, 200 horsepower, crankshaft should be forged in one piece and should be heat treated and machined. The ITP should identify inspection requirements for crankcase, cylinders, accessory equipment and components, drivers, intercoolers, aftercoolers and separators, suction and discharge dampeners, and lube oil system. An inspector should verify manufacturing by checking dimensions against applicable drawings, including machined surfaces for flatness, surface finish, and level. The following is the list of inspection tests usually specified by the purchaser within the ITP. PMI test on major pressure containing parts, as well as parts that are in contact with the process gas. Visual inspection of major casing, weld fabrication and piping. Hydrostatic test for pressure containing parts and piping. Leakage test for cylinders, mechanical run test for compressors, and performance run test of compressors and associated equipment. Purpose of mechanical run test is to verify the assembly integrity as being free from rubs, excessive vibration and noise, lubricant leaks, and overheating. The source inspector should confirm that the run test was performed in accordance with vendor's written procedure. Results of tests are correctly documented. And the purpose of final inspection is to verify dimensions are per the compressor, general arrangement, compliance with standards, instrument and connection tagging, piping compliance to PNID, proper piping support, electrical and instrumentation wiring is in compliance with the drawing, junction terminal box mounted and correct per drawings, nameplate contain correct information, are in compliance with API 618 and purchase order documents.